Two coding agents can use the same model. One leaves you with a suspicious diff and a prayer. The other ships a clean pull request with tests, logs, and a tiny blast radius. This is fluid coding and AI, and today we are talking about the layer that makes AI coding agents reliable, the harness around the model. Most coding agent debates start with the model name. GPT, this, Claude that, leaderboard number, context window, tool use score. Those things matter. A weak model does not become senior because you wrapped it in YAML. But in daily engineering work, the difference between useful and dangerous is usually the loop around the model. Can it see the repo correctly? Can it run the right commands? Is it isolated? Does it leave evidence? Can a human review the result without spelunking through a chat transcript? A chatbot can suggest a patch. An agent can check out a repo, edit files, run tests, read the failure, repair the change, and summarize what happened. That sounds obvious, but it is the real product boundary. OpenAI describes Codex tasks as running independently in isolated environments that are preloaded with the repository. GitHub describes its Copilot Cloud agent as working in an ephemeral development environment where it can make changes and run tests. The shift is from answer generation to controlled execution. Here is where the story gets weird. If you only look at familiar benchmark headlines, coding agents can look almost solved. OpenAI reported GPT-5 at 74.9% on SWE-bench verified. Anthropic reported Claude Opus 4.1 at 74%. The mini-SWE-agent maintainers even report more than 74% with a deliberately minimal agent design. Then the harder evidence hits. Scale's SWE-bench Pro Public Leaderboard put GPT-5 and Claude Opus 4.1 around 23%. OpenAI also later argued that SWE-bench verified no longer measured frontier coding reliably. So what is an agentic coding harness? Think of it as the software layer that turns model output into bounded engineering work. It includes repo instructions, setup scripts, tools, sandboxes, permissions, tests, logs, and review gates. The model decides what to try next. The harness decides what the agent can touch, what commands are available, what evidence counts, and when a human needs to step in. In other words, the harness is where vague autonomy becomes an inspectable workflow. The first reliability layer is boring in the best possible way: project instructions. Codex reads AGENTS.md files and builds an instruction chain from global and project guidance. The public AGENTS.md site frames it like a README for agents, with setup commands, test commands, style rules, and repo conventions. That matters because every team has tribal knowledge. The test suite needs one environment variable. The front end must use a specific package manager. The back end has one migration command nobody remembers until it breaks Friday afternoon. Put that memory where the agent can reliably find it. The second layer is the boundary. OpenAI's sandbox docs describe the sandbox as the thing that lets an agent act autonomously without unrestricted access to your machine. Codex Cloud also blocks internet access during the agent phase by default, because web access can create risks like prompt injection, secret exfiltration, malware downloads, and license-restricted content. That trade-off is not bureaucracy. It is the difference between the agent can act and the agent can act inside a box you understand. Permission fatigue is real, but no boundaries is worse. The third layer is deterministic control. Claude code hooks are a clean example. Anthropic describes hooks as shell commands that run automatically at lifecycle events like file edits, task completion, or requests for input. The important phrase is deterministic control. You do not hope the model remembers to format code. You make formatting happen. You do not hope it runs the narrow regression test. You wire that check into the workflow. Hope is not a build tool. It has terrible error messages. Then there is tool access. The Model Context Protocol, or MCP, is an open standard for connecting AI applications to external systems like data sources, tools, and workflows. That is powerful because a coding agent can reach issue trackers, docs, databases, browser tools, and internal systems through a common interface. But every new tool expands the blast radius. Reliability now depends on schemas, permissions, provenance, logging, and safe defaults. Giving an agent tools is not the same as giving it judgment. Verification is the layer everyone wants, but it is also easy to misunderstand. SWE-bench is not just a scoreboard. It is a harness that gives the agent a real GitHub issue and a codebase, then applies the patch and runs tests. The SWE-bench repo also moved toward a fully containerized Docker evaluation harness for reproducibility. That is good. But tests are still evidence, not truth. OpenAI's work on SWE-bench verified found that some issues and tests were underspecified or flawed. A reliable agent should produce evidence. Changed files, commands run, failure seen, test. For a real repo, start simple. Check in AGENTS.md or equivalent instructions. List exact setup, test, lint, type check, and build commands. Run agents in a clean container, a cloud environment, or a scoped local sandbox. Keep the network off by default, then allow list only what the task needs. Keep secrets unavailable unless the task explicitly requires them. Require changed files and verification commands in the final summary. Add deterministic hooks for formatting, tests, protected files, and notifications. Then track outcomes. Opened, merged, reverted, failed CI, required human rewrite. The harness does not make a weak model brilliant. It cannot replace reasoning, domain knowledge, or a human review on risky changes. But it can remove a huge amount of avoidable failure. Wrong setup, missing tests, unbounded commands, hidden assumptions, mystery diffs, permission prompts that train you to click without reading. The model is the probabilistic core. The harness is the engineering system around it. So when you evaluate a coding agent, ask less, which model is inside, and more, what evidence does this system force the model to produce? If this helped you think more clearly about AI coding agents, like the video and subscribe to Fluid Coding and AI. The next time an agent impresses you, look past the demo and inspect the harness.